Chemistry Review numbers 11 and 12. 11 says, which characteristic of water best explains its ability to dissolve a great variety of materials? In order to know this, we need to know a little bit more about water. Remember that water is H2O. And when I draw a molecule of water, it looks something like this. It kind of has a Mickey Mouse shape to it. So I have oxygen and two hydrogens. Now the way that these bond together gives it this Mickey Mouse shape. And what happens is that the hydrogen end has a slightly positive charge and the oxygen end has a slightly negative charge. Okay, and there's a lot of explanation that I could go into for this, but just know that our H end has a slightly positive charge and the oxygen end is slightly negative. So I'm going to look at this, and what happens is that in order to dissolve something, it has to be able to break it apart. So if I have something like NaCl, which is sodium chloride, which is table salt, all right, our sodium has a positive charge to it and our chlorine has a negative charge to it. When I put salt into water, this positive end of sodium will stick to the oxygen end of my water molecule, because opposites attract, positive and negative attract, and then the negative chloride end is going to stick to the positive end of my water here, the hydrogen side of my water. So it is because of this shape that water does such a good job of dissolving other materials, because it has a partially positive and partially negative end. It can stick onto these and actually pull them apart because it's a fairly weak bond between these. So if I look at these, it says its transparency in light, which is not helping it dissolve. Its electrical conductivity, well, it looks kind of like electrical conductivity because you're seeing charges, but just be careful here because that's not what this is showing. Electrical conductivity means that it allows electricity to flow through a lot of water. So if I have a cup of water, it allows electricity to flow through. And just so you know, water itself does not conduct electricity. You have to have something dissolved in the water in order for it to in order for it to conduct electricity. So that's not it. Its physical state of matter, it's a liquid. Well, liquids do dissolve things better than, say, solids, but that's not why water is so good. It's so good because of this molecular arrangement, because of how the molecule is arranged, which allows it to dissolve things. Now, based on that, we can answer number 12 as long as we know what these terms mean. It says, for 12, which of the following properties causes attraction between molecules of liquid water? Well, what I was just showing you with this whole Mickey Mouse shape, it has a positive end and a negative end. Well, another water molecule is going to be attracted to that because, as I said before, opposites attract. So when you see water molecules put together like this, if I were to draw a bunch of them, the positive end of one will always be attracted to the negative end of the other. We call that polarity. Polar meaning opposites, right? One pole versus the other pole, just kind of like the Earth has a North Pole and a South Pole that are opposite of each other, right? And magnets have a North Pole and a South Pole which are opposite of each other. So these are polar ends, they're opposite ends, and that causes them to be attracted to each other. So what we're looking for here is the term polarity, because those polar ends attract one another.